Hello, this is Satbir. The topic of our discussion in this video tutorial is quadratic function. A quadratic function is a function of the form ax square plus bx plus c, where a, b, and c they are constant. Here, the important information is x, which is the input or the variable of the equation. Its degree must be 2. So this function is called quadratic because of it is degree, because the degree of the function is quadratic. So that's why this function is called quadratic function. Let me give you a few examples of quadratic function. F of x is equal to x square minus 3x plus 2. This is a quadratic function. Or f of x is equal to x square plus 2. This is also a quadratic function. G of x is equal to x square minus 3x. This is also a quadratic function. Let me give you a few examples of the function which are not quadratic. For example, if I write f of x is equal to x to the power 1 half minus 3x plus 1. This is not a quadratic function because the degree of the input is a 1 half, which is not a 2. And there's another example of a quadratic function, f of x, not a quadratic function, x square minus 3x plus 2 divided by x minus 1. So this is not a quadratic function because it has a division. So it is a rational function. So rational function are not a quadratic function. Now let's discuss some concept of the quadratic function. The first concept we discuss is the root of a quadratic function. A real number r is called a root of the quadratic function. If I take this as an input and plug into my function, it will produce 0 as an output. So those number which produce the output as 0 are called the root of the quadratic function. Again, let me give you an example. If the function f of x is equal to x square minus 3x plus 2, and if I substitute or evaluate the function at 1, I will get 1 minus 3 plus 2, which is equal to 3 minus 3, 0. Therefore, x is equal to 1 is a root of f of x. There can be a more than one root. For example, you can see that if you plug x is equal to 2, this is also will be the root of that quadratic function. Now, but the question is that how to come up with those number which will produce 0 as an output. There is a systematically way or mathematically formula to calculate all those input which produce 0 as an output, and that is known as quadratic formula. So this formula give us all the input which will produce 0 as an output. Again, let me give you an example. If f of x is equal to the same function 3x square minus 3x plus 2, and if I use the quadratic formula, first I need to calculate what is my a. A is the coefficient of x square. What is a b? B is the coefficient of x. And what is c? C is the constant term. And now if I plug all these information into my quadratic formula, I will get minus b, which is a negative 3. Here will be a plus minus, and then there is a square root b square, which is a 9, minus 4 times ac, which is 8. Whole thing is divided by 2a, or 2 times 1 is just 2. So it's going to get positive 3 plus minus 9 minus 1 is 8. And so 9 minus 1, 9 minus 8 is 1, and square root of 1 is 1. So if I use the positive sign, I will get 2 because 4 plus 3 plus 1 is a 4. 4 divided by 2 is 2. And if I choose negative sign, I will get uh, basically 1. So as you can see, there are two roots, x is equal to 1 and x is equal to 2 for this quadratic function. Now the next question is how we can use these root to understand the quadratic function a bit more. So the root of the quadratic function help us to actually plot the graph of the quadratic function. The graph of the quadratic function is always parabola. So that's the one property of the graph is. And it will be a upward parabola or downward parabola are decided by the coefficient of the leading term or the coefficient of x square. If the coefficient of the leading term is a positive, the parabola is always gonna be upward. But if the coefficient of the x square is a negative, then the parabola is going to be downward. And also the parabola will intersect the x-axis. How many times it will be determined by the root of the quadratic function. If the root of the quadratic functions are real and distinct, there are two roots, it means the parabola is going to intersect the x-axis at 2 points. And that exact location of the root will be, for example, this is the R1 root and R2. So this will be the quantitative values where the graph of the parabola will intersect. If there is only a one root, or this is also called a double root, then the graph of the parabola only gonna touch the x-axis. So it will touch if there is only a one root. And it will exactly touch at the point where that root is. If there is a no root, there is a one situation when you get the negative sign inside of the square root. So for example, you're using this quadratic formula and you get a negative sign inside of the square root, it means there is a no root. So no root situation is parabola not even touch the x-axis. It is like basically will be above the x-axis. We do not touch the x-axis at all. And all these situations will repeat if the coefficient of x square is a negative, and all the three different situations will arises depending on the root of the parabola. Let's take one more example. We have a quadratic function for x square minus 3x minus 1. And first we will use the quadratic formula to calculate the root of this polynomial. So first I find what is the value of a, b, and c. Once I have those value, I will substitute in the quadratic formula. I fill all these informations here in the quadratic formula, and then I simplify these expression. So I get two root. I get the root x is equal to 1 and x is equal to -1, 4. So here, this is my x-axis. So this is a x-axis, this is a y-axis. So as you can see, there are two locations where the parabola will intersect because there are two roots. The first root is a 1, so this is a 1 and this is a 1, 4. So that's the first information I have. The second information is also coming from this 4, which is a positive. So it means the parabola is upward. So parabola is upward and it will intersect at two locations because there are two different root of this quadratic function. So this helps us to basically actually to plot the graph of this parabola by having the information of the leading term and also the root of the quadratic function. So here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem.